Hello, welcome to this video on PySide6, looking at Python programming using the QGraphicsView and QGraphicScene. First, if you're one of my regular subscribers and this doesn't interest you, before you swipe away, please can I ask you to leave a quick comment. This channel usually concentrates on electronics and maker projects, and whilst this is still related to some maker activities, I'll explain shortly, it's a bit more niche than I would normally do. Or, if you're a first-time viewer, this is the sort of thing you're interested in, please leave that in the comments too. I want to make sure that my videos are relevant to a wide audience. It's really useful to know if you're finding them useful. Also, if you do like the video, please hit the thumbs up button, as that is really helpful. Now I can give a proper introduction. And this is related to a maker project, as it is part of some software I'm programming to make it easier to make laser cut models. These are some of the models that I've been making using this software, although I would say it's still far from being ready for most users. I also feel that programming knowledge is important for many maker projects, and this is based on Python PySide, which is based around the Qt framework, which I'm also using for an interface to an electronics and maker project that I'm actively working on. The reason that this video is so specific is that whilst I've created software using PySide and Qt before, I've never actually used the QGraphicsScene, which is a way to draw objects on the screen. As I've mentioned in one of my earlier videos, one disadvantage with PySide is the lack of examples and community documentation, and I really struggled with this at first, so I hope this will help some people that are looking to do something similar. In fact, I spent a lot of time trying to implement things that just weren't necessary, because PySide can handle them for me, and that didn't work because I was trying to make it work in a way that QGraphicsScene just can't handle because it's designed differently. So hopefully this will be helpful for those looking to do something similar. I won't actually be using my current project for this video, as that's already over 4,000 lines of code and is far too complicated for a simple explanation of these features. So I've created a simple demonstration program instead, which will show you how you can get started using the QGraphicsScene. This is the application that I'm creating, and this is shown on a Raspberry Pi. You can use PySide on other operating systems as well. Specifically using PySide6, and I did have to install this separately. I will include the instructions on my website, but I'm using virtual environment VM for this. PySide2 is included in the repositories, but not PySide6, so it's only a few extra steps to install. And I'm just going to open the file. It's going to a bit of rendering to do. But once it's done that, I should be able to show you what it does. It's this white rectangle here that represents the QGraphicsView or the QGraphicScene. I've actually got a single QGraphicsView but multiple scenes, and I can switch between the different scenes on here. But for the purpose of this video, I'm just going to show a single QGraphicsView with a single QGraphicsScene, just to keep that part simple. But what I am going to show is how these are grouped together. And this is a wall, and it's all built up of individual elements for all the different bricks, well, particularly the mortar between the bricks, the different elements of the window. These are all different objects, but I've grouped them all together on here, and I can pick them up and drag them and move them around as one group. I can zoom in using the scroll wheel, so I'm holding down Control and moving the mouse scroll wheel backwards and forwards. I can move the object around. I can resize the window, and I've got all that space to work at. If I zoom in far enough, then I get the scroll bars that appear, and I can use the mouse wheel to use the scroll bars as well. And a lot of that is actually implemented by the Qt framework itself. I didn't have to manually code all that, which is something I was trying to do, and it turned out I didn't need to do that. Also show that if you've got multiple objects, you can move them independently. So here's some multiple objects, I can move those around. This is more or less what I'm going to be demonstrating in this video. that's it for now. So that's just a brief look at what I'm wanting to do and how it's going to look in the overall application. But for this, I'm going to move to a much simpler application just to make it clearer. So here I am in Thonny. This is on the Raspberry Pi again, and just a reminder that it needs PySide6, and I had to install that as a VM, and I've set Thonny to use that as the executable. There's other ways of doing this. If you're running it on the command, you can run the activate command first, but I've just done that in Thonny. So I've really just set up a very basic program here. I'm going to be doing it very much object oriented, and I've already split my main window into a separate program file, so I'll just show these together. This is the overall program. This is the program just to start up. It just creates the application, creates the main window and shows that, and then starts the execution. We go on to the main window. I've created a subclass of the QMainWindow class and used that instead. And I've just set this with a fixed size, and this is the important bit. So you first create the scene called the QGraphicsScene, and then you use the view, or create a QGraphicsView, and you have to pass it that scene. And then I've set this as the central widget of this main window, so when I run this, I've just got this one window. And then this rectangle represents the QGraphicScene, which is part of QGraphicsView, and that is the same as that rectangle I had in my bigger GUI application that I showed earlier. So first I'm going to just create some objects that we can display on this, and then I'm going to show you how you can enable things like that zoom option, and we can group the objects together so they can be moved around. So the first thing I'm going to do is to add some shapes that we can manipulate on here. I'm going to just put these in the init for the main window. I wouldn't normally put them there, but it's just going to make it simpler for this example. I'm going to actually start by creating some pens and a brush. The pens are used for the foreground colour of a shape and the brush for the background. So I'm going to put green pen equals Q pen Q.green, and I'm going to give them a width. Oops. So the reason I'm creating these is just to differentiate between the different shapes, but also if I just use the default, it's a really thin black line, not that easy to see on the screen. So do some more. And I just need to add some imports for QPen, QBrush and Qt. Well, just Qt's already imported, so that's okay. So let's from okay, so there's the pens and brushes, and now just add some rectangles. I'm going to call these variables called rect1, rect2, rect3. Will allow us to manipulate them afterwards. I'm just adding these as individual lines. You probably want to create these perhaps in a list so that you can iterate over them, but just going to create these individually. As you can see, it's position X and Y, and then that's width and height for the rectangle, and then it's the colour of the pen. So I'm going to put these the same size but all offset from each other so we can see them. And we're just adding them to the scene. So the scene, remember, is the QGraphicsScene. So I'm going to give them the black pen. I'm going to use the brush on this one to give it a background colour, and I'll explain that a bit later, but really it just shows you that you can add a background as well, a background fill. We can just run that, and you can see we've got the three shapes here. Dragging and dropping doesn't do anything at this stage, which is what I'm going to show you next. So the QGraphicsScene can actually handle all the drag and drop itself, and this is a great thing, is that it's really easy just to do. Just setting a flag, QGraphics item is movable. Now I do need to import QGraphics item. I realise I don't need this Q button, that's from something else, so I can. So if I put a QGraphics item there, I can then use that, and I just repeat this for all three. So say if it was a list, you could just iterate over them. But I'm just doing it manually here just to make it easy. Now if I run this again, what you'll see is that I can move these different objects. I can also use this to illustrate one of the other reasons for using the QGraphicsScene is that it can handle scroll bars. So if you go beyond the limits of the screen, you see you automatically get these scroll bars, allowing you to scroll around, move between them, and you can roll them with the mouse wheel as well. So that's got us going. Going to have a look at a couple of other things now. The next thing I'm going to demonstrate is item groups, and this was quite important for mine because, as I say, that was made up of lots of different components. But the reason I've coloured that one in and not these two is because I thought it makes it easy to see which ones I want in the group. So I'm going to put the two with no fill in into the group, and the one that's filled will stay outside the group. I'm just going to go to where we've added them, and you can create the group. You could create an empty group, but you still provide it with a list. But generally you would create a group based on a list of items you wanted to put in the group. So let's call this rect group. I'm going to put it on the scene. Create item group. So if you wanted to create an empty group, then you still need this empty list put in there. But I'm just going to put the first one in. So I could put rect1, rect2, and then that would put those two in that group. But just to show you how you could add ones afterwards, I'm going to use rectgroup.add to group rect2. Now this isn't going to work at the moment, but I'll explain that in a second. So this won't actually work because these are no longer individual objects. You can't select them anymore. You can still select that one, but these two, they're tied together as a group. So what we need to do is replace these two set flags as movable and apply that to the group instead. And now what you'll see is that if I select either of these two, the two will move together. So whether I select the red one or the green one, they'll both move together. And if I move that one, that moves separately. That's how you can use the item groups, and I say it's particularly useful if you've got a lot of objects that you want to be able to control together. The final thing I'd like to do is show you how to zoom in and out using the QGraphicsScene. And this is where, when I first tried, I went completely the wrong direction. I was doing the wrong thing. I was trying to do it within my own code and scale up the size of the objects. And one, that's not necessary, but also it confuses the graphics scene because it's not really designed for doing that. Instead, we just use the QGraphicsScene, and this is actually really nice because it's only a few lines of code. So we're going to put this on the main window, and I'm just going to add the ability to zoom in and out using zoom in method. And all I'm going to do is put self.view. Remember, this is our graphics view rather than our graphics scene, so it's self.view. If you don't have view accessible as I have here, then you can get to this using the main window, so self.ui.graphicsView instead. But if you've already saved it here, then that's the easiest way to do that. And you just do self.view.scale and then give it a scaling factor. So that's going to scale the X in the direction twice the size and the Y twice the size. And to zoom out, it's exactly the same, but you use fractions instead. View.scale 0.5 will give you half the size on the X and in the Y direction. And that's all you need to do. There is a slight gotcha, I'll come to that in a bit, but if you can call those, then that allow you to zoom in and out. I wanted to be able to put this on the scroll wheel on my mouse, and that's a bit more difficult into how you intercept that scroll wheel. And I came up with this solution. It's not necessarily the best. Other people might have other suggestions. If you have them, then please put those in the comments. But this way works. And basically what I'm going to do is I'm going to replace QGraphicScene with my own subclass of QGraphicScene. Easiest to show. So just going to create a new file. Going to need QGraphicScene to be imported. And QWheel event wheel event, which is what we're going to use to capture the wheel. And I'm also going to need to import Qt, as I'm going to need that for modifier. I'm going to create my own class, QGraphicsScene, and I'm going to inherit QGraphicsScene. So what that means, it's going to be inherit basically everything that QGraphicsScene's got. So you've got all the functionality of QGraphicsScene just by doing that. I'm going to override the init. And one thing I'm going to do here is I'm going to bring in the main window. Now, it is still accessible via parents and things like that, but I just find this is quite a nice way of doing it. If I bring in the main window here, then I can access it, and I can access those zoom methods that we've just created. Hopefully it'll come clear once I've added the rest of the code. I'm going to call the parent constructor and I'm going to store the main window variable. Now I'm going to override the wheel event. So this wheel event method already exists in QGraphicsScene. By overriding it, it will use mine rather than the one that's in QGraphicsScene. This is going to capture any events with a wheel. But I only want to capture them and deal with them if the control button's pressed. So if, just check that the modifier's there, and just going to do a Boolean comparison to see if the control modifier is pressed, which means the control key is pressed down. If so, event.ignore will mean that I am not going to capture the event. I'm going to let it pass back to QGraphicsScene. And we're going to return. But if the control button is pressed, then I want to just capture how far the scroll has been scrolled. Now I don't actually need the value. I just want to know, has it gone in a positive direction or a negative direction, because that determines whether we're going to zoom in or zoom out. So if the number of pixels is greater than 0 in a positive direction, then we're going to call, say, self main window, that zoom in function that we just created in the main window. But if, I guess we could have put an else if here, but I'll just, if it's in a negative direction, then I'm going to call zoom out. And because I've used the event this time, I'm going to accept it, which means I don't want you to pass it on. Otherwise, when you zoom in, the QGraphicsScene will also try and scroll at the same time. So I'm going to save that as the graphicscene.py. I'm going to import that into the top of here. And I'm going to use that instead of this one. And remember, the one change I did is I added that I need to pass the main window. And the main window is self. So now, if I've done all that right, I should be able to press play. And no, I haven't. I've probably got a typo here. I've missed 2 underscores there. Let's try that again. There we go. So, as before, we can still view these. If we pull these far apart, you can see the scroll bars appeared. If I scroll the mouse wheel, it still scrolls up and down as it did before. But now, if I hold down the control key and now scroll, it zooms in and it zooms out. And it's a scaling factor. So each time I press forward, it goes twice as big, and each time I go out, it becomes half the size. Now, one little thing here is that if you want it to be an absolute value, and I do on my example because I want to be able to have a menu that allows me to, say, jump into a certain amount of zoom, then you can't use this zoom directly because this is always going to scale relative. So what you need to do in that case would be to, one, track what level of zoom you're in, such as having a variable called zoom level is how I do it. And then you have to reset the transformation. So you do self.u.reset transform. And then you would replace this with your variables. So if you do reset transform, it goes back to the original size and then applies that scale. Whereas if you don't do that, then it always applies that scale on top of the current transformation. Okay, I hope that makes sense. I won't actually do that for this because I'll just leave it as that. So at the end of this, we've created the QGraphicsView. We've created the QGraphicScene, which in my case, I've replaced it with ViewGraphicScene because it allows me to add that zoom. I've created item groups that are manipulated together and a separate item there, and also showing you how you can access the mouse wheel so that you can create that zoom option. So I hope that's been useful, and I will have the details on my website, including the source code, so you don't need to be able to capture this from the screen. So look in the description for more details of that. If you have found it useful, please give this video a like, and I look forward to seeing you on a future video. Thanks for watching.